We are Group 1 and we're going to present a research study about the inventory of the natural and engineered drainage networks to Pasig River. For the introduction, the Pasig River is an important river system since it connects two large water bodies in Metro Manila, namely Laguna de Bay and Manila Bay. The flow of Pasig River through the urban areas comes from its upstream portion located in Laguna de Bay, then moves through the Napindan Channel and joins the Marikina River at the boundary of Pasig and Taguig. It links further with San Juan River and finally flows out into Manila Bay. The Pasig River is classified by the DENR as Class C, which is primarily intended for fishery, recreation, and supply for manufacturing processes. The problem target. Pasig River is vulnerable to flooding in times of very heavy rainfall, with the Marikina River tributary the main source of the floodwater. Since Pasig River is polluted, the required velocity of the river flow isn't met. Significance of the study. The significance of the study is to know the current status of the tributaries and esteros to the Pasig River, and recommend ways to improve the drainage networks to avoid flooding. The scope of location. This study aims to investigate and assess the drainage network to Pasig River. This study includes an inventory of the natural and engineered drainage network to Pasig River.
To be able to understand the data gathered, different formulas were used. For esteros, uniform flow is estimated. To get the value needed, Manning's formula is used to compute the discharge capacity. For SI unit, the formula is V equals 1 over N R raised to 2/3 times S raised to 1/2. While for English unit, the formula is V equals 1.49 over N R raised to 2/3 times S raised to 1/2. Next, for the drainage, probable peak discharge is computed using the rational formula Q equals CIA. Peak discharge is the time when the river reaches its highest flow, though peak discharge have delays since water takes time to find its way to the river. Here are the schematic diagram that we got. The dimensions of drainage mains. Next are the location of discharge observation points. Probable peak discharge that can be computed using the rational method.
Pasig River was cited as the world's 8th most polluting rivers. Since tons of waste are dumped in the Pasig River, its water quality and flow area are affected, and the designed discharge capacity of the river is not reached. For example, the San Juan River, despite being the shortest among the major tributaries of the Pasig River, it is the most polluted. Due to the tons of garbage, the San Juan River overflows when medium to heavy rainfall hits the area. Overflow of the river causes flooding, affecting the residents living around the area. Because of this, BRRC frequently holds rescue operations to save the residents trapped in their homes during the overflow of the San Juan River. Another example is the Marikina River that causes flooding to Marikina City, which is deemed as one of the most flood-prone cities in the Philippines. One of the major catastrophes experienced by Marikina was when the Marikina River overflowed when the Typhoon Ondoy hit the Philippines in 2009. As a result, Marikina City live streams the water level of the Marikina River to monitor its rise during rainfalls. Additionally, the average ratio of current flow capacities against designed discharges are about 50% in Pasig, 80% in Lower Marikina, and 20% in Upper Marikina. Flood control ratio is especially low in Upper and Upper Marikina. Given the current design and status of the tributaries of the Pasig River, wherein flow area has been reduced mainly due to houses in river course, sedimentation, and dumping of solid waste, World Bank and Japan International Cooperation Agency seek to further improve the Pasig River by dredging and floodway restoration to maximize the capacity of the river and reduce the flooding.
Here are our conclusions based from our research. According to the Japan International Cooperation Agency, the drainage facilities are composed of 15 major drainage pumping stations, 74 km of esteros or creeks, 35 km of drainage mains or outfalls, and about 400 km laterals. Major drainage pumping stations are old and drainage channels have lost their original design capacities due to the pollution caused by waste. One of the recent technologies adopted to improve the drainage network of the Pasig River was the blockchain technology, which was used to clean the 25-kilometer waterway of the river. Despite the efforts of the government to control the water quality of the Pasig River, its condition continues to worsen. The data obtained from the Pasig River indicate that the target water quality for Class C waters have not been achieved since 2003. The main problem when addressing water quality problems is insufficient government funding. The lack of monetary resources had resulted in the weak implementation of government projects. The government has not been able to provide enough wastewater facilities to treat huge discharges coming from domestic, industrial, and solid wastes, with the majority of this waste being discharged directly into the river without proper treatment. Another factor is the lack of support from residents living in Metro Manila to cooperate with projects and mandates. Effective solutions to resolve the conditions of its water quality management cannot be found without the participation and cooperation of its residents. The government needs to listen to its residents and reflect their opinions on the government's watershed management policies, whereas the residents should endeavor to resolve their own water resource problems. With that in mind, the residents of Metro Manila would be able to bring back the once pristine waters of the Pasig River and many other water bodies.
So based on the problems we have encountered, we have come up with the following recommendations. First is the dredging of esteros or creeks and the clogging of drainage mains are significantly effective to recover the original function of drainage system in the core area. Second is the plastic-eating bacteria, which was recently found in Zambales. If this can be developed in Pasig River, it could contribute big help in eliminating plastic waste. Third is if the structures nearby esteros are removed, pollution can be lessened. Fourth, maintenance of whole of drainage must be maintained or secured as often as possible. Next is the necessity of pumping stations should be maintained. Last, the building of permeable pavement has better effect on reducing runoff coefficient and flood peak, which can effectively reduce the pressure of urban drainage and reduce the risk of stormwater flood.